Good evening, ladies and gentlemen, and welcome to the second annual SAICE Joburg branch of Avant-Garde Forum. I am Stella Zile, also known as Star, and I'll be your MC for this evening. We're all very privileged and honored to have all of you guys attend this forum today. We'd just like to welcome Sisanda to come forward and give us an overview of last year's event and all the presentations that went on last year. Thank you.
I'll just stand aside just to be away from the ray of light. Thanks a lot for coming through. I think the most important thing on this day is the support that we get from other SAICE members. I'll just give a brief overview of SAICE Avant-Garde. What is it? Where does it come from? And what are we actually trying to achieve here? So my name is Sisanda, and I'm from the SAICE Johannesburg branch. And a year ago, we met as a branch and we said, you know what we need is a platform where young professionals in the engineering space could come and share, showcase, or just show ideas that they have. And these ideas could be in their various formative stages. They could be theoretical or they could be post-application. So we are not very pedantic or specific in terms of where that idea needs to be. But I think the most important thing that we wanted to support is get those ideas out where you could share and get critique in terms of their value and their applicability. And that's how we're here today. So last year we started with 4 speakers, which is similar to this year. We had one gentleman, Alvino Bezetenote from the University of Pretoria. He was a final year student and he was presenting on the use of electric methods, that is cathodes and anodes in soils to stabilize clay or plastic soils. The second speaker was Estienne Rotz from Oricon, and he was sharing his ideas of how individuals from one branch could share work with individuals from another branch. So in other words, you could be sitting in Cape Town, South Africa, and how are you able to share work with a branch that is in Australia and so forth. The third speaker was Dan Avushia from NL, and he was presenting on wind turbines and a formula that he had derived for the calculation of the depth of foundation for wind turbines. How a wind turbine generates energy and how that is stored and how that is sold to a power supply like Eskom and so forth. And then the fourth speaker who's also here is basically my man here. Can you just give a wave, please? Refilwe Lediga. The Refilwe presented on the use of 3D printers in construction. That is the use of special types of cement that is extruded to actually build houses, and what the future of the technology is. So this year we've got a nice mix as well. I think we've got 2 pavement engineers, 1 pavement engineer, 1 pavement technologist. We've got 1 asset management or management consultant, and then we've got 1 environmentalist as well. And those are the 4 speakers we'll have, but I will not deliberate too much on that. I think this is where we come from, this is why we're here, and we're really looking forward to the speeches today. There's a time allocation of 25 minutes per speaker, and then we will allow a 10-minute Q&A, and the reason for that was the idea is to plant the seed and then to start the conversation, and then depending on the question and interaction that we get from the 4, one can see how far we want to take that conversation. So I'll keep it brief. Thanks a lot.
Thank you, Sisanda. Our first speaker will be Dr. Peter Kraus, and he's working at SMEC in the Management Service Department, and his topic is sustaining water supply. So I'd just like to welcome Dr. Peter Kraus to the stage, please.
Hi. Cool, thanks for this opportunity to share. I'm just going to be presenting one of my projects that I worked on, and I think, I don't know how many of you are in the water sector, but this will be about water. You may not be in the sector, but I hope you find it interesting. Okay, so over the last few months, over the last year, water's become considerably more and more in the news, and it feels like it hasn't
left the news yet. Talks of dam levels dropping. I don't know if you guys remember the vol last year was at critical levels. Cape Town's been suffering this year a lot as well. I don't know if you guys are aware of water loss and non-revenue water, how much water government is losing. But there's an indicator that we use called non-revenue water, and it gives us a percentage of how much water is not being accounted for, how much water is lost. The government's producing water, but they're not getting the money back out of it. And on a national level, we're looking, this is the data you can see. The first thing you can see is we're sitting around 40% of any water that's produced or purchased is not being sold to a customer at the end of the day, and that's lost somewhere in the system, either through a leaking pipe or through a meter that's not working, or through a meter that's being bypassed. But the other thing you can notice is that the information only goes up to about 2015, so the information is quite outdated, and information is what drives the management of water services. Okay, here's another graph looking at surface water storage, so how much water is available in our dams, and you can see that this year it's looking pretty good, so it's in the green over here, but last year it was pretty critical. This is again at a national level, so it kind of looks alright, but you can see that this pattern here is very different to the last 5 years, and these patterns we'll see, it's about a 10-year cycle that we'll see these type of patterns again. So that's nationally, but you can see this was taken off the website from Department of Water and Sanitation last week. This looks exactly at that graph, looking at how much water is available in our dams. You can see that the coastal areas are suffering quite a lot. Their water levels are still quite low. So how do we manage that? How do we make sure that water still comes through to the communities who need it? So the project that I'll be talking about in Pukwane local municipality, I don't know if anyone's aware of that, but it's basically Northern Cape, very dry, just north of Kimberley, and yeah, I'll take you guys through that. So the project happened between November 2015 and was supposed to be until about November 2016. So about a year project. Main driver was for making sure that the municipality had a strategic framework within which to ensure that the communities have water, so that they can manage the inadequate supply that they've got. They go for a couple of weeks without water every year. They had very high percentages of non-revenue water, which we recorded between a 6-month period. It was about 80%. And then also, the other thing that they've noticed over the years is that their water supply is increasing a lot. So they're buying a lot more water, they're having to produce more water, and they want to understand why. Why is that? And then finally, just looking at water security in terms of job creation and ensuring that industries can still operate. It's very much driven through agriculture, and agriculture requires water supply. Okay, this again is the local municipality. I don't know if you guys are aware of it, but there's Hartswater, Pampierstad, Jan Kempdorp, and then down, down, down is Kimberley. So this is kind of the region. It's a very, very beautiful part of the country. To give you some stats, there are about 20,000 people in the municipality. They're seeing an annual population growth rate of about 2.2%, so it's not considerably high. But they're seeing considerable water supply growth. So their population growth is about 2.2%, but their water supply growth is about 8.2%. So it's growing exponentially faster than the area is. And to put that into perspective, that was about over a 6-year period that it grew at about 8%. But in the year from 2015 to 2016, their water demand grew by 30%. They want to know why. This is just a graph showing the water, the non-revenue water, looking at it year on year on year. And again, it's based on the information we had available. So this indicated that it was the information that was presented to national government, and the average was about 60%. When we took the information over the last year, the non-revenue water rose up to about 80%. And again, what are the measures to reduce that level of non-revenue water, to reduce their supply requirements, and then also to ensure that this doesn't happen again in a couple of years. So I think one of the key success factors in this project was looking at upfront, looking at some of the questions that we want to answer through the project, and looking at it from an output perspective. So once we've developed a strategy for the municipality, that they can leave knowing that their framework in their mind is exactly what's on the paper that they can implement at the end of the day. So we ask questions like, how can the savings be quantified? How can we look at the municipal area and say, this is how much water you can save if you do this? What do they need to implement for that? What type of resources do they require? How do they actually implement it? So if they've got hundreds of projects that need to be implemented to reduce their water demand, how do they prioritize the programs so that they can sustainably manage the municipal water infrastructure? How can they take water demand management into their future planning? And what are the financial benefits of these proposed water conservation and water demand measures? And how can they be optimized? Okay, just back to the project. So our aim was to develop a strategic framework for reducing water losses and increasing internal revenue from water metering within the municipality. That was the main focus of it. So we went in as consultants. I'm a consulting engineer. Went in looking at how we can develop a framework and a strategy for sustainable water services. We performed a desktop study, we collected data, and then all the data we collected we put into a hydraulic model. So we had to incorporate data from the billing system, from GIS, from the asset registers. So we relied heavily on the information that they had available. We developed models of their hydraulic water distribution network, and then went out to site again and did some data collection to see how accurate or inaccurate our model is and how practical it was to actually use that. Based on all the information we had, we then went back to our drawing board and said, what measures can we implement to see a change in the municipality? One of the initial things we found was by earmarking certain areas in the municipal area, we cover about 95% of the population. So we only looked at the key towns in the municipality and found that majority of the water and majority of the population sits in these regions. So we prioritized our scope around those areas in the municipality. Just to give you an idea, this is the water cycle. So from raw water to treatment, through a distribution network to the customer, and then down pipes, a sewage network of some form, to the wastewater treatment and back to the river again. For water demand management, we looked specifically at how do we reduce the burst pipes, the leaking pipes, the aged infrastructure, looking at your physical losses. So that's between your bulk pipelines, your reservoirs, and your distribution network. And then also looking at revenue enhancement for the municipality, so looking at meter management, looking at your customers, and any water losses beyond the meter, where customers aren't necessarily paying for their water, that's a loss for the municipality. So those, we could break it up into those two areas. I'm just going to go through a whole bunch of interventions that we proposed, and then I'll focus in on a few of them. But in order to manage a water network, you've got multi-faceted approach. There's no one approach that'll work. So you need to have some form of infrastructure monitoring system in place, like a telemetry system. We also proposed earmarking the water distribution network into smaller areas so that would be easier to manage. And then also looked at, okay, that's more the management side of it. How do you manage your network? But then also looked at the network itself and identified that infrastructure was going to need to be replaced in the very near future, and that there were areas where the infrastructure was very poor already. So we needed to look at replacement programs and active leakage detection programs, as well as social programs, looking at water conservation awareness and education, and then institutionally looking at standard operating procedures, capacity building and skills development, and then finally looking at your consumer behavior through tariffs. How do you set tariffs that are cost reflective, and how do they implement that into their bylaws? And these are not easy tasks to do, and it really required a lot of buy-in from the municipality. As an external consultant, going in and saying this is the status quo of the municipality, no one really wants to hear that. I really had to get buy-in from the municipality in going through each of these interventions. I just want to touch on one of them, which was pressure management. So in a water distribution network, where the pressure differential is very high, you exacerbate pipe bursts, and your infrastructure expected useful life gets reduced quite drastically. So we looked at, based on our model and based on using sensors out in the field, we established that there were areas where there was very high pressure and very high pressure differentials throughout the day. And by reducing that, we estimated that the municipality could save quite a substantial amount of water per annum, which then can be converted into revenue savings. But it requires actual installation of infrastructure, it requires maintenance of the infrastructure. The municipality had actually implemented some of these programs before, but there wasn't the institutional memory to actually maintain that infrastructure either. Okay, this is just an idea of how we took a network, and then we just separated it based on the pressure differentials within the network, as well as trying to reduce the amount of new infrastructure that you require in order to sectorize the network. Okay, and then on the billing system and the meter management, we also looked at interventions of how to increase the number of meters that were being billed on a monthly basis. So it's about 20,000 households there in the municipality, and only a fraction of them were being metered at the time. So what are the root causes of that, and how can the municipality go about improving it within their operations on a month-to-month basis? So we also looked at when meters are replaced or found to be faulty, how are they replaced, and how can the replacement time be quicker? So I don't know if you can see the graph, but that just shows how for each of the different areas in the municipality, the number of meters that were read was quite variable. So there wasn't a consistent trend in metering the customers, but you can see that less than half of the customers were being metered at the time. Okay. Yeah, so for me, I was the technical lead on this project, and I interacted with the client on a regular basis. But the main problem, or the main challenge in this project was time. We were appointed for a 12-month period, and then when we went to the first meeting, the municipality said, well, we actually need to spend the budget before the end of the financial year, which turned almost a 12-month project into about an 8-month project. And we had to account for that within everything that we did in all our analysis, and also managing the client's expectation throughout this process so that they have a thorough assessment of their water services in a realistic time frame. So that was one of the biggest challenges and developments for me. It really was a great experience, actually. Yeah, and like I said, I was part of the technical team. I led the technical team and reviewed a lot of the outputs that were done, and really just needed to assess whether the information that was being provided from a couple hours away was realistic, that we could rely on it, that it was representative, that the models and the strategy that we develop out of it is actually going to be useful and beneficial to the municipality, and whether we needed to investigate further. Yeah, so just in terms of some technical works that we performed, we developed hydraulic water distribution network models. I don't know if you guys are familiar with these, but they provide an overview of how the network is running. So especially when a lot of the pipes are interconnected, where are the areas with high velocities within the pipes, high pressures, low pressures within the network, and it's very interesting when you have the data, the quantitative data behind it, and you go to someone and you say, this is what we found, then they say, oh yeah, that makes sense. We have that all the time. That's really very, very valuable, thank you. But if at the beginning of the project we didn't have that information, so we had to go and ask questions and say, where are the problems in your network? And they said, well, we don't really have problems in our network. Or sometimes it's here, but yeah, we don't really. So it was interesting seeing that change as you provide data, that the quantitative data is so valuable for the municipality, but they didn't have the skills at the time to actually implement it themselves. So that's just some of the sensors and the technology that we use to actually go and verify what we had modeled theoretically. And it was very, very interesting to see where there were differences in our model, going back and updating our model with different scenarios, and then going back to the clients and saying, this is the information you provided, this is what we found on site, this is what we think is going on, and then again providing input and feedback and saying, no, actually this is how it is, or no, actually you're right here, that's fine. So it's a lot of up and back and forth with the client. It was really interesting to see that interaction and be part of it. Okay, I just wanted to highlight that I said their water supply or water demand had grown rapidly over the last couple of years. At the time, so this is about a year ago, just over a year ago, they were using their water supply that they had estimated for each of the different towns. They were about 5 years ahead in terms of planning, which meant that if they wanted to ensure that their water supply is sustainable, they needed to build whatever infrastructure 5 years ahead. So if they had planned to only have it in place by 2030, they now needed it 5 years earlier if they kept increasing their supply at the current rate. So it has long-term knock-on effects as well. So the main beneficiary for the project was the community and the industry. It secured water supply for socio-economic development, but for the municipality as well, we looked at reducing the operational costs and operational inefficiencies. And then we developed a business plan for them and looked at the potential revenue that there could be increased through their collections, through reducing their inefficiencies, and looked at it not as an infrastructure cost or capital layout that they have to do, but more of an investment opportunity. So saying, if you invest in infrastructure now, this is the return on investment that you'll see over time. Okay, an important component of the project was setting key performance indicators, and we looked at it over time, developed models, and looked at about an 8-year return on investment, which is quite manageable for the municipality, but their main challenge was resources in terms of staff to actually manage the rollout of the plan, the strategy. Okay, so just in summary, there's no silver bullet to managing water, to ensuring that water is provided to the communities. There was an urgent need for the municipality, the Kwane local municipality, to implement the strategy that was developed. They had low revenue collection, exponential water demand growth, and then they experienced water shortages during periods of the year, which really had a material effect on the economy. And so we developed a strategy for them that was multifaceted and enabled sustainable operations of their water services and infrastructure. The lessons I learned, my role as a consulting engineer was to support and enable the client. It wasn't to just do the project for the project's sake, but to really look at after the project. How is this practically going to be implemented? How is the project going to add value to the municipality, to the client? I also know that time is not always available, and that mustn't be limited by knowing everything to the nth degree, but must really apply engineering judgment and assess what can we do in order to provide the best value for money for the client in the time that's available, and to meet them in their constraints as well. Then finally, with water demand management in this project, as an engineer, I really had to integrate multiple skills, from technical skills, social skills, communication and financial skills, to develop a plan that was realistic and that the municipality could actually buy into at the end of the day. Cool. Thanks.
We'll now have a 10-minute window for any questions. So if anyone has questions, if you could just kindly raise up your hand so Bradley can give you the other mic.
Hi, Peter. I just want to find out, okay, from the map that you did depict on the presentation, in terms of the challenges, do they have a lot of farming community in that municipality? And if so, were the farmers also involved in your project in terms of making an awareness with them as well, that, you know, whenever they use water, they need to think of ways in terms of its savings, and then also make sure that they work hand in hand with the municipality in saving water, since it's a scarce resource?
Yeah, so There are lots of farming communities in that area. It's actually very beautiful. It's a canal that was built just after the Second World War. That is basically, if you zoom in there on Google Earth, it looks like a matrix of canals, and the farms are in between those canals. So the farmers abstract directly from the canals, and they don't abstract through the municipality's sources itself. So they've got their own licenses. So the scope wasn't to go and investigate why they're using a lot of water. The scope was just to investigate within the town regions, within the residential and commercial areas, why is there a lot more water? Why is there increase in the water going on? It was done from an institutional level, more looking at what can the institution do before going out to the community and saying, what can you do to assist us? But it was more saying the institution, the municipality, didn't know where they should be prioritizing their efforts. They're very short-staffed, and before they went out to the community, they wanted to just have a plan in place and get their house in order as well.
Thanks for the presentation, Peter. When you look at the non-revenue generating segment, the graph you just showed us, what percentage would you say is due to losses or due to government's deliberate actions not to charge people or charge citizens deliberately? I know because in townships sometimes they don't actually pay for water.
Yeah, so I mean, they're different estimates, but for a lot of the municipalities that I've worked in, it's about 40 to 50% is due to the metering side of things, and about 50% to 60% due to physical losses. So when I look at non-revenue water, it's not that it's water running down the street necessarily. I mean, that does happen, but it's mainly due to the metering component thereof. And the main issue with metering is that you've got thousands of assets, thousands of meters that have to be maintained, and it's a challenge. It's a challenge to actually maintain that. And in developing countries, I'd say that statistic is very different to, for example, in London or Europe, Americas, where they've got very strong institutions to manage infrastructure.
Hi, Peter. I just wanted to ask, on the project that you did, was it on a tender basis or did you approach the client? And the angle that I'm thinking of is the opportunity for people within the consulting space to actually, at a very concept stage, to identify clients that could greatly benefit from that and actually approach, thereby increasing their chances of actually getting more work. So, well, if you're at liberty to share that, was it by tender or did you approach the client with this idea?
Sure. So a lot of the work I do is tendered work. So this project was tendered, but it's the clients had done this form of a strategy about 10 years ago. So they were aware of the benefits of having a strategy or management plan in place, and that's why they put it out. I speak to a lot of municipalities and go and market and say, these are the opportunities that you could implement, and these are the benefits as to why you do it. And oftentimes it's the clients just didn't know that these opportunities exist. So I'd say you need to have both aspects therein. But yeah, we in South Africa in government work, it's tendered predominantly, and it's an approach that works. Hopefully most of the time, all the time, I hope.
Thanks for the time. I've got two questions to ask. At the beginning, you indicated that time was a little bit of a constraint. And then I just want to find out from you, the time that you completed this project was shorter than anticipated. Were you also compensated to accelerate that process of putting up the assessment until to prepare the report itself? And the other question was to ask you, you mentioned one of your challenges is shortage of water during dry seasons. What were your advice or recommendation to the client? Because your assessment was to make sure that there is always water supply, and then there are no wastage to the system. So what was your recommendation to the client?
Yeah, so I'll answer your second question first. Just in terms of reducing supply, you need to focus on your physical loss reduction programs. So looking at areas where there are high burst pipes, or where there's a high pipe failure, look at pipe replacement programs, look at conservation and education programs to encourage consumers to reduce their demand. But none of those happen overnight. You're not going to change a consumer's behavior overnight, and you're also not going to replace a couple kilometers of pipe overnight either. It takes a lot of planning. So to answer your question in short, we could do very little in those situations. There's very little that can be done immediately, but it's about putting measures in place to manage it for the next 2 to 5 years, or preferably 1 to 3 years, to just make sure that you meet your requirements, and then thereafter look at ways to sustain that and to make sure that the infrastructure gets the best value out of it at the end of the day. So when those situations occur where municipalities are without water currently, it's about managing that and managing the expectations of the customers within those areas as well, and being realistic about it. Does that answer your question?
Yeah, partly.
Okay. And then to go back to your first question about whether we were compensated for accelerating progress, unfortunately, no. Again, tender processes, we bid on a price, and that was the fixed price that we bid on for the project. So we had to get resources in and make sure that we could meet our outputs and all of our quality requirements around the project.
Thank you so much, Peter. If there are definitely no more questions, I think we can go forward to the second presenter. All right, thank you so much, Peter. Our second presenter will be Sibongile Gumbi. She's from Royal Hospital DHB, and she's an environmental scientist. Welcome, Sibongile.
Good evening, everybody. As our chair lady has just said, my name is Sibongile Gumbi. I am an environmental scientist by profession. I am going to be touching on one of my projects that I've worked on as well, in terms of the environmental issues that we normally explain. Just to give a little bit of a background on the environmental side of things. The environmental field is one of those fields that are less than 30 years old. The first legislation that was ever designed in terms of the environment, it's called the Environmental Conservation Act. It was actually promulgated in 1989.
So from there, then a lot of people were a bit confused as to what does this environment mean. Maybe just to briefly explain the term environment. Well, it's everything. Well, according to the legislation, environment is defined by saying it's the surroundings in which humans live in, including your air that you breathe, the water that we drink, and us as human as well. We are also part of the environment. So meaning our well-being is also dependent on the air that we breathe and the water that we drink as well. So as well as the animals that are in the world. So each and every species or human beings, we are dependent on one another. So if we harm the other component of the environment, as I had mentioned, we will then also be affected as human beings. So therefore, we need to then make sure that the components that make up the environment is well looked after. Well, as I said, I'm just gonna touch on the project that I did a couple of years back. It was called Johannesburg Strengthening Project. The project is more about increasing the energy supply within the country. Well, what happened is that ESCOM had done a feasibility study a couple of years back, and then they then determined that in future we are going to be, actually it was estimated by that feasibility study that by 2012 we're going to run out of electricity supply within the eastern region of Johannesburg. So then from that feasibility study, they then went on to implement a project which is going to address that issue of energy shortage within that region. From my side, we were appointed to do the environmental impact assessment for that project. As I said earlier on, the environmental field, it's new, so from there then we had to then make sure that the environmental issues are addressed up front before the project is actually implemented in terms of construction at a later stage. The photos that I have here in my presentation, it's some of the power stations, and substations, as well as the power lines that were affected by this project. That's why I thought let me just bring them in this presentation. As I said earlier on, that due to that feasibility study that was done, the project came about as a result of that feasibility study. So now, as I said, we were then appointed to do the environmental work for the project. In terms of its location, well, even though it was termed in Johannesburg East Strengthening Project, but it also fell within the borders of the Mpumalanga province. For an example here, the Mota Power Station, where the power line, the source of power will be coming from to connect within the substations around Johannesburg. It was coming from that Mata Power Station, which is located in Kriel, Mpumalanga province. As I said, actually the project was located between the two provinces, the Mpumalanga and the Gauteng province. And then the Mata Power Station, in which we were sourcing power from, it's about 30 kilometers from Johannesburg if you go the direction of Mpumalanga. The transmission power lines, in terms of the planning, was that it was going to be taken from the Kriel power, Mata Power Station and be linked to Jupiter B substation, which is located within the lower Germiston area. And then also some other substations within the Ekurhuleni areas, as well as the city of Johannesburg area, in terms of the power supply as it was planned. Some of the districts that were affected within the Mpumalanga area, you're looking at Govan-Begi local municipality, the Gert-Simande, within the Gert-Simande district municipality. As I said, since it was a huge project, it entailed the construction of 400 kV power lines, as well as the 132 kV power lines and the associated substations of that size. And then, as I said, most of the substations, though, were located within the Gauteng province. It was only the power lines that were taking power from the main power station in the Mpumalanga, then bringing it around here within the Gauteng province. This is just the locality map of the study area. As I said, it was just within the two provinces, and then also the areas. It also shows the areas that were mostly affected within the Gauteng province as well, which are City of Joburg and Ekurhuleni. Again, these are just the structures of the different power lines that you get. On my left-hand side, this is your typical monopole structure. These structures are normally built within the areas that are confined. In terms of if the space is not that wide, then they are forced to build these monopole structures. The monopole structures also assist in terms of visibility, because sometimes these structures, they tend to create a lot of visual impact. And then they go and build these what you call monopole structures, just to limit the visual impacts within the area where they are built. Then at the bottom here, this is your typical 400 or 275 kV power station. The photo that I have here below was taken from the Ingula pump station, which is located in Ladysmith, KwaZulu-Natal. It's one of the Eskom's projects where they've built an underground power station. So the power station is just built on top, and then, sorry, this is a substation. The actual power station, if you look at this road, it leads you to the main power station underground, where everything is being operated. And then they brought in this substation to then connect to the power lines, which then transmit power throughout the country in terms of the energy demand. Well, in terms of the environmental impact assessment that we do, it was actually taken from the Constitution, of which I believe we're all familiar with. When you look at Section 24 of the Constitution, it has a section which talks about the environmental rights. As I said, the environment, has a lot of components which include us as human beings as well. So, Section 24 states that everybody has a right to a clean environment in terms of air, water, and everything around that human being. So, meaning now that that right needs to be protected by doing development or projects responsibly, and making sure that the rights of the people are not affected. So then from that piece of legislation, then as I mentioned earlier on, there used to be an old act called the Environmental Conservation Act, which was promulgated in 1989. seeing that that act was old and it did not include components that are now relevant to what is currently happening in terms of the environmental sphere, a new act came into being, which is called the Environmental Management Act, and that one was promulgated in 1998. Then under that legislation, we then had the environmental regulations. From those regulations, the environmental impact assessment are then included, and then from there, they then mandate an independent environmental scientist or a practitioner to conduct the environmental impact assessment in making sure that the environmental rights of people are protected, as I had mentioned earlier on. As I said, in terms of the regulations, it lists the activities which might result in the detrimental impacts when they are being developed. In terms of those listing, according to the previous act, the first regulations which were promulgated in 2006, it only had 2 listings, which were listing 1 and listing 2. And listing 1 being activities that, even though they will cause harm into the environment, but they are not that severe compared to the activities that were contained in listing number 2. So therefore, in terms of the studies, even though those activities will not result in the severe impact, still you needed to do a basic environmental study just to determine whether the predicted impacts will really be insignificant as stated in the legislation or not, and also make sure that those minor ones that are being picked up to result in significant impact, they then mitigated accordingly. And then when you look at listing 2, as I said, it's those that are definitely going to result in the severe environmental impact. So therefore, in terms of the processes, the basic assessment, it's a process which is less in terms of the time frame. You're looking at about 6 months to complete that process. Whereas with the full environmental impact assessment, which has 2 phases, the scoping phase and the full EIA phase at the later stage, you're looking at a period of 12 months to do the studies or undertake the entire process, and before then you are given an environmental authorization for that. Again, because legislation revolves as new challenges come on board. As I said, the ones that we used for this project, it was the regulations promulgated in 2006. There has since been then the different amendments to those regulations. The ones that are currently in operation, well, they have been recently promulgated now in April 2017. As I said now, in terms of the listing, we now have 3 listing notices that needs to be taken into consideration whenever you do the environmental studies. They've included listing 3, and then in terms of the listing 3, it's those activities that are taking place in a very sensitive areas. For an example, when you look at Kruger National Park, if you want to do a development within the Kruger National Park, then you need to comply with listing 3 notices, because Kruger National Park, for an example, is seen as one of those very conservative areas, and very sensitive. Besides Kruger National Park, even within the Gauteng region as well, there's plans and strategies that are being compiled by the local authorities. Therefore, then they create conservation areas, which we normally call them CBAs, which stands for Critical Biodiversity Areas. Those areas that need to be protected whenever you want to take a development or have a development in those areas. So those areas then, if you are indeed going to be taking or having a development in those areas, you then need to comply with those listing 3, what you call now, use listing 3 notices to do your environmental studies. In terms of the process as well, the environmental process for listing 3, it is also a basic assessment process, which is the one that I mentioned that it's normally shorter. You're looking at about 6 months to complete the entire process. Okay, in terms of the process itself, the environmental process, you first need to lodge in an application to the Department of Environmental Affairs, which are mandated to look after environment or make sure that they authorize projects or developments in terms of the environment, or they are the body that has been mandated by government to look after the environment. So therefore, then you need to lodge in an application with them, and then once you've lodged in an application, you then conduct the environmental scoping study, which I mentioned earlier on, just looking at those impacts, the environmental impacts at the high level, and then from there do a plan of study for the next process. Once you've done that, you then you submit your reports to the department for approval. Once the department has approved the environmental scoping report, they then allow you to go to the second process, which is the full environmental impact assessment. And then from there, once you've done the process as well, you submit your reports, and then the department reviews your reports and then give you an environmental authorization. Before they can give you that authorization, for an example, if there is an information that is lacking or additional information that they require, they will notify you that we need certain study done or we need certain information to be included within the reports. Therefore, then you cannot get the environmental authorization right away. But if your information has been comprehensive enough within your reports, once they've done their review, they then come back and issue or give you that environmental authorization. Once the environmental authorization has been issued, you then need to notify the people. Something that I just forgot to mention, throughout that process, you need to involve the public or the interested and affected party throughout. So once you've lodged in the application, you need to notify people that might be affected or are interested in a project or the development that you are planning, and informing them about the project so that they can also give in their input into the project to make it a success. And then once you've obtained your authorization as well, you then also need to notify them that a positive environmental authorization has been issued for the project. Therefore, a developer can continue with that development without any issues because they do have the approval from the Department of Environmental Affairs. Sometimes, in terms of the authorization or the public as such, it is not always as straightforward as one would think. Because once you've notified the people that there is an environmental authorization that has been issued, they have the right to appeal if they are not happy with the decision. And then if the facts that the public is presenting to the minister are not valid, then the minister can then continue and make their inform the appellant that their appeal is not valid, therefore the project will continue as planned. And then if maybe it is valid, they will then notify the developer or look at the issues that are being raised by the appellant, and then notify the developer then to rectify those issues before then another authorization is issued for the project. So meaning it is put on hold for a while before the development can take place. If the authorization is granted and there isn't any appeal in the process, and then the environmental, the developer has about 30 days to notify the department that he or she is planning to start with the development within 30 days. That's because of the legislation. Well, this is just to explain that the reason why the environmental study is being conducted is just to, as I said, it's just to identify the impacts in terms of being the biophysical and social impacts. As I mentioned, that the public is normally involved in the process of the environmental studies as well, so that they can point out issues that the environmental consultant that is conducting a study might not be aware of. Then therefore it makes it easier if such issues are addressed within the project upfront before an environmental authorization is issued. And then those impacts are then rated in terms of their significance. And then, as I said, the public then is involved by, through notification, and also there's also public meetings as well, and advertisements that are placed in newspapers notifying people about the project. And then the impacts, they're actually looked at in terms of the construction phase as well, the operation and the commissioning phase of the project, just to make sure that the developer takes into consideration the impacts and mitigate them accordingly. And then there's also a document that is being drafted, which is called an environmental management plan, which then assists the appointed contractor during the construction phase to implement these mitigation measures in preventing the impacts that have been identified and those that might not have been identified, but they are then prevented by implementing this plan. Well, I'll just go quickly because my timekeeper is just telling me now that I have limited time. In terms of the project that I was just referring to, as part of the environmental assessment process that we undertake, we need to also look at the options of achieving a certain goal. You can't just say, for an example, I want to build a house on spot number A. And then to find that, okay, when the environmental study is being done, and then it is discovered that actually it's going to be impossible for you to build a house at point number A because the area is very sensitive. Maybe there's a lot of water in that area, so meaning in terms of the stability of your house, it won't be stable enough, it will collapse, anytime. So therefore you need to also have another plan, meaning plan B, to actually build your house, because at the end of the day, even though the Department of Environmental Affairs, gives decisions at the end, but they also want to look at that different options have been considered, when in achieving a certain goal that the developer wants to achieve. So for an example, like in this project as well, we had to look at different alternatives for these power lines being taken from the Matla power station that I mentioned to reach Johannesburg and connecting to different substations within the province. When then these options were presented, some of them then, when the studies were done, it was discovered that they were located in very environmental sensitive areas. So then those options were then eliminated, and then we then continued with those that were more feasible. For an example, if I might just go back to the previous slide, we had, in terms of the power lines, we had three options. So option 2 and option option 2 and option 3 were then eliminated completely during the scoping study because of the sensitivities that they were located in terms of the environment. We were then left with alternative 1. Again, because within the next phase of the environmental impact assessment process, we needed still to assess the options. We then looked at other ways of achieving that by diverting alternative one in certain areas where there was less sensitivity in terms of the environment. In terms of, maybe if I can just point out here, as you can see in this area, this is your wetlands and watercourses where the power line was going to be crossing. So looking at all those sensitive environmental areas in terms of water, then certain diversions had to be made. And again, this power line was also located closer to the N17, which links Mpumalanga and Gauteng as well. So the other thing as well, because now the traffic, so in terms of our stakeholders, the Sandra was also one of our stakeholders, because we needed to liaise with them, as same as the Gauteng Department of Transport, in terms of their roads and the location of the power lines, so that the planners from ESCOM side can plan these lines accordingly without affecting the traffic on the road, as well as not affecting the environment as well. These are just options as well for the power stations that we're going to be connecting into the power line we're going to be connecting to. So we also had to look at options for the substations as well, because those were new substations that needed to be built in order to supply the power locally. This one is the Sebenza power station near Edenvale. Again, this is another one as well. This is now the Jupiter substation. As well, we had to also look at the different options of it, and then from the studies, then I'll show at the end of the presentation as to which options were then preferred at the end in terms of the alternatives. Again, as you can see here, there were a lot of water courses close by, and also some residential areas as well within this next to the area where the substation was being proposed. Again, with this one as well, as you can see, this is the power line. So the power line was going to be connecting the Krekol from the Krekol substation to the Sebenza substation as well. So from there as well, we had to look at options in terms of achieving our goal. This one was the SLN substation, which is located between Pretoria and Kempton Park. And then this one was the North Rand, so it was the Kempton Park and Edenville substation as well, in terms of the power line and the connectivity of the substation close by. This one was the Prospect substation near Albertine, and then connecting to the one in Edenville. So in terms of once the studies were done, and as I said earlier on, there were environmental sensitivities around it. So in terms of the less environmental sensitivities on the options that were being looked at, these were then the options. For an example, in terms of the studies that were done, the Avifona study for the Sebenza substation, it preferred option A, and then for the other substations, for the Sebenza substation, it was option A, the Krekol and the others, and then for other substations, there weren't any sensitivities. Same as the other studies as well, they looked at, in terms of their discipline, they looked at the sensitivities, and then from there, they then nominated the preferred one. As I said, this is just the studies that formed part of the environmental impact assessment, which, as I said earlier on, it was Avifona, biodiversity, your hydrology, soils and agriculture, your wetland, the heritage, and social. In terms of the challenges, if I can just wrap it up quickly, it was that, you know, it's a bit difficult to develop something in an area where there's already buildings or in existence. So it's easier if maybe you find an open land where you can go any other direction, obviously taking environment into consideration. So some of the other challenges that we had is that we needed to find the feasible options that were not going to affect the residential and business areas, but at the same time, you know, achieve our goal at the end that we had planned earlier on. And this is just a list of the areas that were being affected within the Gauteng region. While the benefits of the project, obviously, by having more energy or electricity within the country, it was just to assist in terms of stimulating economic growth, as well as creating employment opportunities, and also attracting new investors as well in the country if we have such a, you know, a basic need such as electricity. Okay. Well, I won't go that much. I don't know, Sisanda, am I still fine? And okay, sorry, I think I've taken up a lot of time that was planned for me. I thought it was going to be quick.
Thank you, Zwongi. Are there any questions from anyone in the crowd? No questions? Going once? Okay. Thank you so much, Zwongi. Our third speaker for tonight is Kristen Moon, and she works in Aircon, and she's in pavements. I'll hand it over to Kristen.
Thank you. Okay, as you know, I'm Kirsten Milne. I'll be presenting my fourth year research at the Varsity. It's titled Assessing the Influence of Speed on Road Seal Cohesion Fatigue Failure. So, have you ever gone on your morning run and noticed the aggregate missing from the road? Have you ever wondered why? This is basically the burning question I want to answer. So this leads me to my objective, which is to determine the influence of speed in relation to cohesion fatigue failure of a surfacing seal using a dynamic shear aerometer and a polymer modified SE1 bitumen binder. So basically my friend here is showing you where the cohesion zone lies. Cohesion is between bitumen and itself, whereas adhesion is between the aggregate and the bitumen. So for this research, I'll be looking at just the cohesion zone, and in order to conduct this, I'll be looking at the bitumen properties and behavior. So a DSR, what is it? Basically, it's a machine that has two plates. The bottom plate is stationary and the top plate will rotate relative to the bottom plate. And okay, move on. So basically what you'll get from this machine is you'll get a phase angle, a complex modulus, and a deflection angle. So what are these things? Okay, so your deflection angle is, the deflection angle is when your top plate rotates relative to the bottom plate. It will rotate in a circle, so it will be measured in radians. And the value you'll get from it is basically the higher the value is, the easier it is for the top plate to rotate relative to the bottom plate. The next thing you'll get is your phase angle. So basically, as your top plate rotates, your bitumen in between the sample over here will experience various stresses and strains. So the lag between the stresses and strains that the sample experiences will be known as the phase angle. So basically, a high phase angle would be, imagine honey between the two plates. So it'll rotate a little bit slower. So before I move on, the complex modulus is basically the change in shear stress over the change in shear strain. So this gives an indication of the sample's resistance to deformation, so basically tells you the stiffness. You'll then get the storage modulus, which is the elastic portion, and the shear loss modulus, which is the viscous portion. And this makes sense because you'll have your phase angle between there, and if it's 90 degrees, it's viscous, and if it's 0, then it's elastic. So now, in order to continue with the research, you need to be able to determine when failure occurs. So when you look at the material properties, when your G star is high and stiff, it will make it easier for the bitumen to stack. So imagine having a fizzer. If you have a hard fizzer, it's easier to snap it than compared to a soft fizzer. And when your phase angle is low, meaning the material is more elastic. So compare trying to pull a hard fizzer apart as opposed to a soft fizzer. You'll want a soft fizzer in the road because then your aggregate will be able to move with the vehicle as it moves over the road. Whereas if it's hard, it'll just snap off. So now if you look at a DSR test, if you conduct the test, the first sample to snap will basically fail first. So this will tell you which a fast speed or a slow speed will be more detrimental to a road. So my methodology, I start with a binder, which is a polymer modified bitumen SC1 binder. Then you'll prepare the samples. I conducted a parallel plate test, which tests cohesion, as you're testing the bitumen with itself. Then you'll conduct a stress control time sweep on a DSR at a constant temperature. Basically what a stress control time sweep means is you're keeping the stress constant over a specific period of time. And then I'll vary the frequency between 5 and 15 Hertz. 5 Hertz will represent the low vehicle speed and 15 will represent a high vehicle speed. Then I'll analyze the results. So as you can see, I didn't quite get what I wanted to. There was no clear trend from these results, so it was inconclusive. So I had to carry on and see what else I could do and see where I could draw up any kind of relationship. So next we have a thing called the black space diagram. Basically it's a plot between your G star and your phase angle. And if you bear in mind what I spoke about earlier, for basically to be detrimental to a road, you'd want a high G star and a low phase angle. So what this is telling us that 15 Hertz over there is the most detrimental compared to 5 Hertz. So 15 Hertz high speed, more detrimental to the road. So then next we had a look at the rheological index. What this is typically used for is to test the aging of the bitumen. So when a bitumen is exposed to the atmosphere, it ages and it hardens. So this applies to what I'm doing as well because I want to see if bitumen is hard. So if I test a sample and it tests closer to an R value of 3, then it's more likely to experience failure. So as you can see here, the 15 Hertz plotted closer to an R value of 3, but one must also note that the 5 Hertz is also detrimental as it plotted within the 2.3 to 2.7 boundary. So now if you've taken everything that we've learned and try and visualize it, basically you'll have your G star, which is your stiffness. If failure were to occur, your G star should drop. Because if you have your two plates and it snaps, it will all of a sudden turn a lot easier. So your G star would measure lower. And your deflection angle would measure higher because it turns a lot faster. So if it turns more, you'll have more deflection. So then we end up with my postulate. Basically what this is saying, it's a 3D surface of frequency, deflection angle, and G star. So these are most of the results that I got from my testing. And if you were to visualize failure, as I've just done, the surface would basically drop. So the theory is, if you were to conduct a test and you were to get your values, if your values were to plot below the graph, your surfacing seal would experience failure. So basically what this is telling us is speed is bad. So the faster you drive over a surfacing seal, the more chance you have of having the road experience failure. So if your car drives over fast, the aggregate will just whip off, which is what you would see in the first picture I showed you when you went on your morning run. So how does this help us? Basically having a better understanding of how surfacing seals work will allow you to utilize materials and build roads in a more cost-effective manner. Thank you.
Are there any questions? If there are any questions, please raise the hand so Bradley can see.
Hi, Kirsten.
Hi.
Susanna here. I thank you for your presentation first and foremost. And do you have any intention of taking the research further, or are you done?
I've applied for my honours and masters next year, so hopefully I'll get the opportunity to.
Super. Because as I was listening to your presentation, I just had two thoughts that sprung into mind. Because you were looking at the relationship between cohesion failure
Yeah.
and basically speed. What I would be interested in is to see the relationship at varying temperatures. In other words, if you are in a hot region or you're in a cold region, what would those relationships look like? So you could almost get to a performance grade type of assessment in terms of at this temperature, at these varying speeds, this is the behavior of the material. And then at varying temperatures, at the same speeds, this is how it behaves. So you could track that relationship. And then also I saw that you use a modified binder. So I'd be interested in the different types of modified binders, AE2 and the like, versus pen grade bitumen as well, and seeing what their behavior is. So there's almost two other properties that you could almost investigate. That is, what other modified binders are there, and what are their behaviors versus your conventional pen grade, and then as well at different temperatures. And then I'd really be interested to see what that relationship is. Yeah, but thanks a lot for that.
Thank you.
Hi, thanks for the presentation. I've got a short question. I need to find out from you, how do you view this in uphill? What happens to the binder, because this take a scenario of a heavy vehicle like a truck, it's not speeding. Don't you think you can find something from there as well?
Part of it's in my script C. What I did look at is in a road, I looked at, okay, it's a residential road, so I doubt there will be many heavy vehicles. But what I did notice is on the uphill, there wasn't as much aggregate loss as the downhill. And I would say this makes sense to me because as a car drives downhill, it speeds up a lot more than it would when you go uphill, just how you drive. And also when you turn corners, I think that it could also just be the movement of a car turning a corner. There's also a lot of aggregate loss there. So it's, I think heavy vehicles, I think they drive at a bit of a lower speed. So I think we'll have to look into that.
Thank you, Kirsten. And we'll have our last speaker being Sisanda, and this is his brainchild basically. So yeah, the pressure is on Sisanda. Thank you. You can come forward, please.
I'll be presenting on rigid pavements, possible alternative approaches. And for those who aren't in the pavement space, rigid pavements are your concrete pavements, as opposed to your flexible pavements, which is where you'd use granular material or stabilized material. So I'll start off with some disclaimers. First and foremost, I currently work for Royal Haskoning DHV. But at the time that I undertook the study, I was employed by JG Africa, so I think I'd like to give them their dues as well. My presentation will be based on a component of the entire study in the interest of time. So we looked at the roads component, that is the pavements, and we also looked at the stormwater. I wasn't involved in the stormwater, I only had a look at the rigid pavements. I'll also be looking at the solutions that were relevant for this particular project. So I'm not in any way trying to say that this will be a generic solution for all types of scenarios. So it's very important to keep in mind that I have unique problems for a unique environment, for a unique client. And this is what I found worked. And I think the intention today is to plant the idea to say that there are these alternatives that one could have a look at when doing their design. There are two proprietary products that I had a look at. One being slab on ground, which is designed and produced by Structural Solutions. Structural Solutions is a subsidiary of Group 5, and they assist in terms of the design as well as the sourcing and implementation where required, and because they're a contractor, they're also able to implement. The second product that I used was the PRS NeoWeb, which is a product that is produced by K-Tech. It's similar in appearance to the Hyson cell, which tends to be more well known, but it's not exactly the same. I think there's a lot more engineering and thought process behind the stiffness of the material, and what type of loading and what type of environment and what type of dynamic loading will it be used for. So those are the two products that I use for this particular scenario, but there might be other similar products that could be as effective, but for the project that I worked on, this is what I found to be useful. So just an introduction to the project. The project was Exaro Mine in Grootegeluk, in the town of Liphalale. The project value was 233 million. The size of the site, now the site not being the entire mine, but the area that I had looked at, which was the concrete lined areas, was 12 hectares, which, as you would know, is not a very small size. Our appointment for the contract was for the concept, preliminary and detailed design. The client had the intention of doing their own construction supervision by themselves. What they wanted for us to do was to address issues of feasibility, as well as detailed design and preparation of contract documents for whatever a rehabilitation option we found feasible. So our project brief from the client was, simply put, if I simplified, was to develop a maintenance and a rehabilitation strategy for the concrete lined areas, as well as address the stormwater drainage system. The project team consisted of 4 individuals. It was 1 senior and 1 junior geometric designer for the stormwater component, and then 1 junior and 1 senior pavement design specialist for the pavement component. So the presentation, I'll be focusing mostly on the design component for where we've used a relatively innovative technology. It's possible that other individuals are already using this, but from the quick desktop analysis that I've done and talking to colleagues in the industry, I found that the technology that I'm going to chat with you is not used as often as I think that it could be. So that's where the innovation part comes in. So the problem statement that we had to resolve was, why are some of the concrete lined areas exhibiting signs of distress? In terms of what I mean by that is failure. What can be done to resolve the existing signs of distress, and what can be done to mitigate the future advent of any distresses in the concrete lined areas for a particular design period. Our design period was 30 years, of which 20 years they would not be required to do any intermediate rehabilitative or special maintenance. So what we had to look at with the client was that they were not very strong in terms of their maintenance action. So it was very important for us to design an infrastructure that really minimized the burden on them in terms of conducting routine maintenance. So that's why our design period was for 30 years and then 20 years without any special maintenance needing to be done. So these are just images of some of the distresses that we noted on the plant. That is signs of punching within the concrete. We also had shattered slabs. We also had a combination of faulting and transverse cracks. And these are some of the longitudinal and transverse cracks that were noted. There was also faulting there. Sorry, this image is actually joint spoiling. Sorry, this was not faulting, it's actually joint spoiling and transverse cracks that have joined together. So, like I said, there were 3 phases. That was the concept or feasibility stage, preliminary design, and detailed design. So during our concept and feasibility stage, we undertook a visual assessment of the plant. And then thereafter, we undertook a mechanistic empirical design to look at the existing structural capacity of all the pavement structures. And what we found was that some of the concrete lined areas had insufficient structural capacity. In other words, if you had a look at a car that had to pull a load, capacity would be what is the ability of that car to be able to pull that load, which is a function of the torque and the power that is within the car. So if I take that analogy to pavements, it's all about the material that you've got, and then you've got your dynamic or static loads that are imposed on top of it. And based on the number of repetitions of those loads, or based on what is the size of that load, that's what capacity actually refers to. How many times can vehicles drive over the pavement before you get signs of distress? That is what capacity is. So what we found was that if you look at the pavement structure, and if you look at the loads that are anticipated, there wasn't a link there. The existing pavement structure was insufficient. And when we went back and we spoke to some of the older foremen who always worked on the plant, it became clearly evident that at the beginning, when they constructed the concrete lined areas, not a lot of thought was applied to what type of pavement structure do we have to implement for the loads. It was just a case of it was muddy, and they just wanted a surfacing that would get vehicles away from mud and being stuck in the mud. So there wasn't very thought deep process in terms of what is the structural capacity of this pavement structure, and then is it adequate for the dynamic loads that are anticipated for this plant. What we also found was that there was insufficient routine maintenance. That was evident when we looked at things like when you looked at the joints, and when you look at the types of distresses that could have been mitigated while they had started, but they were allowed to continue for some time. And with the ingress of water, that has only just exacerbated that distress. So the following actions were required. We saw that there were 4 actions that were required in terms of rehabilitation and maintenance. One, some areas required complete rehabilitation. So if you look at some of those shattered slabs, I mean, there's not much maintenance one can do on those slabs. So those would be completely excavated, removed, and built from scratch. You'd have special maintenance. That's where you can still do, where you had your isolated longitudinal or transverse cracks, you could still repair those. If you had isolated incidents of distresses, you could isolate that and repair that. So that was special maintenance. Routine is basically all your joints and looking at things that you would do over time at a frequency that is predetermined. And then some of the concrete slabs were actually good, and because of the anticipated loads, one did not need to do anything. So for my presentation, I'll only be focusing on the complete rehabilitation and what are the options that I had to look at in terms of those. So a concrete pavement consists of 2 components. There's the concrete bed that everyone sees, which is the rigid pavement wearing course, and then there's the underlying subbase and in situ material. So, sorry, there's actually 3 layers. So it's the concrete base or wearing course, it is the subbase, and then it is the in situ. In situ meaning that is the material that is in place. So I had to look at 4 options. I had to look at cast in situ concrete base, and I'll show you images later to show you what that is. I had to look at precast concrete base, both of those doweled. I had to look at post-tension ground slabs, and then I had to look at hot mix asphalt. We knew that hot mix asphalt would not be suitable, but knowing the client, we wanted to indicate that we had actually considered it, that it wasn't left out by accident. But looking at the mineralogy of the water, because this was a coal mine, it's a wet process. So what you get is within your conveyors, there's a lot of water which is high in asphalts, which is high in impurities as well. So what you find is that with the mixture of hot mix asphalt would not really be compatible with each other. So we immediately knew that the 4th option would not be worth considering. So we really focus our energies on the first 3. So cast in situ refers to where you prepare, the assumption with this image is you've already prepared your subbase, and now you're constructing your wearing course, which is your concrete base. And cast in situ means that you actually pour your concrete in place. So you would put your formwork up, which is basically your formwork would be on the sides there. You would actually put in all the reinforcing that you feel is necessary for the type of loading you're planning for, and then you would actually backfill it with the concrete mix that you've actually designed. So that's the cast in situ concrete base. Now, they've got advantages and disadvantages, and I'll just run through them as well. So the advantages of cast in situ concrete is that it can accommodate various grades. In other words, if you've got a surface that is not necessarily constantly planar, that is constantly straight, and that has changes in grades, change in shape, cost in situ really is able to adapt to that, because you literally, as long as you can put in your reinforcing, your forming to the shape that you want, you can basically pour it into any other shape. However, at the same time, it does require curing periods before it can be trafficked. So it needs to reach the required 28-day strength before you can allow vehicles to traffic that concrete base. It can accommodate irregular shapes, as I've said. The only disadvantage is that it is labor intensive. And on mines, the general consensus is that for individuals that are not mine workers, they have a preference that your contract period be as short as possible, and that you have fewer laborers as possible, because it prevents less safety risk for them from a health and safety perspective, as well as just from general health and environmental issues. The other advantage of cost in situ is that it can be placed to the required level with great accuracy. So if you find that the team that was actually doing the sub-base has made some errors, the cost in situ tends to be a lot more forgiving in errors in the levels of the sub-base as opposed to the other options. And then the disadvantage with cost in situ is that you tend to require regular joints, and your typical spacing would range from about 4 to 6 meters depending on your design. But you generally have to have those joints so as to allow for expansion when temperatures are high and when temperatures are low, and your concrete actually contracts and retracts consistently. And then precast concrete. Precast concrete is an option where you prepare your sub-base prior, and then you've already, in a controlled environment, in a factory, you've already manufactured all your bases. So this is an example of where it's used highly within the Americas, in the freeway. And the issue they have is that to close down a lane and allow for, typically depending on what type of mix you use, to allow for 7 to, let's say, 21 days to allow that strength to get there, they don't have that amount of time. So their preference is to use precast concrete slabs that are already using the right mix, and you literally put it in place. Now, precast concrete slabs have also got their advantages and disadvantages. The advantage is that there's a reduction in construction time. So your construction time is related predominantly towards the construction of your sub-base layer, and then your concrete bases includes just actually placing it and putting it into place. The disadvantage is that it's not suitable for irregular shapes and variable grades. You literally have to have a survey that is to the millimeter accurate if you're going to use a precast concrete base, because the base is already cast. So the only way that you can have variance is within your sub-base. So your levels have to be 100% correct. Otherwise you are going to get inconsistencies between parallel slabs. The other advantage is a reduction in plant and personnel required for construction. Again, a lot of your plant requirements are for your sub-base. You would only need, depending on the weight of the slab, you would need a device that is going to be able to lift it and put it into place. The disadvantage is that it is not forgiving to errors in levels, as I've said. The other advantage is that upon placement, it can be immediately trafficked, as you can imagine, because it's precast. And with precast, the construction of the base can run parallel to the construction of the sub-base because it's within a controlled environment. And in some cases, you can actually cast your slabs before you even started the sub-base, so that you've already got them prepared beforehand. The disadvantage is that there's no reduction in the sub-base thickness compared to the cast in situ. In other words, if you do your mechanistic empirical design and you say I need a concrete slab of 200, whether you do that cast in situ or precast, that does not affect the thickness of your concrete base. It just affects the fact that your base is constructed within a controlled environment in the case of precast, whereas in cast in situ you actually cast it in place. And then the other advantage is that it allows for easier repair of isolated defects. So what you're able to do there is you're able to leave a client with a number of precast slabs in the event that in the future they need to do rehabilitative action, and then you can leave it there for them. And then what I found particularly interesting was the post-tension ground slabs. Now, when I usually mention this, people get surprised that you would use post-tension slabs that aren't in buildings, that you'd actually use them on the roads. I think the advantage of post-tension slabs is the strength that you're able to get within that slab. So the principle behind it is similar to cost in situ and pre-cost. You still need your formwork all around. Now, what you see there are actually ducts, and in those ducts are basically your tendons. Now, those tendons would be typically steel or whatever material the manufacturer would suggest. And this is what you're going to tension, and this is what actually gives you strength. And then below that, you have to have bedding sheet, which will be prescribed by the supplier. So it's very similar to cost in situ. The only difference is in cost in situ, you would actually have your reinforcing. Whereas here, you don't have reinforcing. What you've got is tensioned tendons. And then in that sleeve are the tendons, and then as well as it's got grouting in it, which further increases its ability to be able to be tensioned. But it also allows it that if there's isolated failure there, because of the grouting, it does not affect the other tensioned sections of that concrete slab. So looking at it at the portion where it will be tensioned, so what you're looking at is these are your tendons, and this is your sleeve, and that shape there is so that when you do cast it, it's actually, that sleeve is actually anchored into that base over there. So that's what it actually looks like, a close-up towards the edge, and that is your formwork over there. And then this is your jacking equipment, and this is what, so what you actually do is you actually cast your sleeves in there as well as the tendons, but they're not tensioned during construction. You allow your concrete base to reach the required strength, and then once it's reached the required strength, then you begin with the process of actually tensioning those tendons, and that's where the strength actually comes from. And then once you're done tensioning them, you can actually cut those tendons beyond the point of tension, and then you can grout those so that you don't have unsightly, open, exposed tendons, especially if you're in an aggressive environment that could attack the steel tendons as well. Now, the post-tension ground slabs has also got advantages and disadvantages. The first advantage is that you get large joint-free areas. You can even get a minimum width of 20 meters length as required. It's uneconomical, however, for smaller areas. So where this tends to work really well is where you've got storage plants or where you've got large concrete open areas. That's when it really becomes economical and it becomes financially viable. It's able to carry excessively large point loads, typically used in harbor containers areas, for example. What we had here on the coal mine was you really had large front end loaders, you had large cranes as well, so you really have high dynamic loads, and that's why this became an option. The disadvantage is that it requires a specialist for the design of the pavement structure. In other words, this is not something that can be done by any Tom, Dick and Harry. It's a very specialized environment, and that's why Structural Solutions has really invested in this knowledge, is because they work for Group 5, so they're the designers as well as the implementers of the technology. The other advantage is that it's able to be placed over marginal soils without them having to be stabilized. So one of the advantages that I found for this was I had sections that had G7 and G9 in situ material, which was inadequate at that stage as it is. So it required to be stabilized. So the nice thing with the post-tension slab is that you can literally place it directly on top of your marginal material, and then you take that into consideration in terms of what type of tensioning and the number of tendons and the spacing of those tendons, so that it's able to carry those loads. So as you can imagine, it's your countries like your New Zealand and all of those places that have got a lot of expansive soils that may require to be removed and replaced with more granular soil. So this saves you in terms of using the in-situ material. You don't have to import material from a quarry or other commercial sources, and that you can actually place your concrete slab directly on top of those marginal soils. Another advantage is that it's able to be thinner concrete thickness than cast in situ or precast. So the strength in cast in situ and your precast is derived basically from the thickness of your concrete base, where the intensity of the load that is applied makes sure that it's within the flexural strength of the material. whereas here the strength is derived actually from the post-tensioning of the slabs. So it's no longer a function of the thickness. So you're able to have a thinner concrete slab because the strength is derived from the tensioning of those tendons, which is within that base. The disadvantage is that it's not suitable for irregular shapes and variable grades, because what happens with variable grades is that you end up having to have a number of couplings to be able to be suitable for that. And the more couplings you have, then the expense actually starts increasing. So it goes back to my point of it's mostly suited for large, open, flat surfaces. That's when it tends to really be suitable. The tendons typically tend to be about 1 meter apart. Therefore, the location of the surfaces can be incorporated in that. In other words, if you have surfaces within your concrete areas, be it columns or you've got pipe ducts, this technology is able to accommodate that a lot more than when you would have to have reinforcing, and then that provides an issue in terms of, well, how do you accommodate these surfaces and these columns? The disadvantage is that it requires a space of 1 meter on each end. 1 meter will be enough working space so that you can be able to put in the device that actually tensions those tendons, as well as if you need to do maintenance so that you can access it. So on the one side where you do tension your tendons, that's where you really need at least about 1 meter access point. The rehabilitation options I had a look at for the sub-base was the conventional cement stabilized sub-base. And then the second option I had a look at was the cellular confinement system. And this is where I use the PRS NeoWeb. So your conventional, although this is not a concrete road, I just want to illustrate typically what cement stabilization is as people know it. So this is typically where you've either got your in-situ material or you've got your imported material, and you literally stabilize it, be it with a milling machine or whatever, with a grader, depending on how skilled your operator is, and you'd actually stabilize that to either a C3 or a C4 cement stabilized. So the initial design we did required a C4 sub-base, so it would have required cement stabilization. Now the advantages and disadvantages of cement stabilization, the one advantage is that contractors generally are well versed in this material, so they know how to actually stabilize it properly. The disadvantages is that it requires curing periods that are excessive, it's very labor intensive, and excavated in-situ material may not be required. So for your C4 stabilized sub-base, you're looking at a minimum of a G6 that's required. So if you've got a G7, G8 or G9 in situ, that's not going to be suitable. What does that mean? It means you have to excavate and spoil that material and import at least your G6, G5, depending on what environment you're in, to be able to get that C3 and C4 quality. So what we had looked at was the PRS NeoWeb. And the PRS NeoWeb, I think, like I said, a lot of people tend to know the heights and cells, but it's not the heights and cells. So there it is there. It's that honeycomb shape. And a lot of people usually ask, so how do you actually implement that? So you initially prepare your in-situ material, and then you can anchor it. Now there are specialized anchors, or you can put in temporary wooden pegs to just hold it in place until you've backfilled it. And then thereafter, you can take out those wooden pegs over there. And then the nice thing is you backfill it with the in-situ material. But first you have to consider, will that in-situ material, after it's been confined by the PRS NeoWeb, give you the stiffness that's required for the sub-base? And that's where you have to undertake a mechanistic empirical design. So what we did was we gave the material specifications of that material to KTEC. We said, this is our material, this is the properties. And then we said, what product would be suitable for these material? Excuse me. So then what they did was they looked at various PRS NeoWeb products with different orifices, but also with different stiffness. Then we had to tell them what type of loading are we anticipating. And then from that, they were able to give us a strengthening factor. So in other words, if your material was 100 MPa, if you actually backfilled it into the PRS NeoWeb, it would have a multiplying factor of 3, which would then result in 300 megapixels, for example. And that would be your input into your design, and then you would assess whether you've got adequate support for your sub-base layers. There are also advantages and disadvantages in using this product. For example, The advantages is you do not need granular material. You can use some of the in-situ material that you've got. The disadvantage is that cellular confinement system is provided by specialist suppliers. So what you tend to find is a lot of the contractors aren't well versed, and some people are scared of using new products for fear of failure. So there is that bit of education that is needed there. The other advantage is the speed of construction and opening to traffic. As soon as the system is placed and filled with material, it can be trafficked. So there you don't need to have curing periods because you're using the material as is. The disadvantage is shaping of the subgrade to the required level. You also have to be careful there. And there's no reduction in the sub-base layer thickness because you're using the in-situ material. And in closing, we just need to keep in mind that there is not one size fits all. One still needs to look at your particular constraints, your particular environments, your particular loading for that pavement structure to see if it's suitable. And it's important to calibrate your expectations versus the constraints. So what does the client actually want? And lastly, availability and proximity to source will affect the cost. In other words, do you have a plant close by? The supplier, how frequently can the supplier provide that product to you? And how is that going to affect your construction time as well? And that'll be it for me. Thank you.
Do you have any questions from Sisanda? For Sisanda? Any questions? Okay, there are 2 questions here.
Hi Susanna, thank you for your presentation. I'd just like to ask you, why was RCC, like roller compacted concrete, not considered as one of the options?
I'm not familiar with that. Would you care to share?
Okay, roller compacted concrete is mainly, well, I'm familiar with it because we use it in dams, and I just did some research that they do use it in pavements as well. It's basically concrete that's slightly stiffer than your conventional type, and also doesn't require reinforcements as well. And it's much more economical, and it's faster as well. So it's basically applied in like layers. But, yeah.
I guess then it would be a function of cost. So I'd be really interested to see if it's economical. And I think also it's a question of considering where the site is, how easy would it be to source it for that particular environment. And then I wasn't aware of that. I think it's a first and it's something I'd really like to research further. And I think it's also what we were working with were very, very high dynamic loads. So if you look at a dam, it's not looking at the type of loadings that we are looking at, where you've got a front end loader and you've got a basically 200-ton crane that actually traffics that. So one would have to look at what type of flexural strength you would be able to get with your concrete and whether that would be compatible with the environment. But it's really something worth thinking about.
Thank you.
Sanga, what sort of strength increments do you get when you use post-tensioning in those applications?
Well, post-tension, it's basically, we are looking at 200, I think we had loadings, about 200 kilonewtons, I think even 750 kilonewtons point loads. So it actually depends on what point loads you're actually looking at. But the strength is, they will find, you just increase the number of tendons to be able to increase the strength that you're able to get from your post-tension. So it's, for lack of a better words, it's relatively limitless in terms of, especially for plant areas and what we want to use it in terms of roads, it's basically limitless in terms of what loads you can be able to carry with that. I haven't had a look at what the ceiling is, but I just looked at it for this particular contract, whether it was suitable or not. It was a pity that the supplier was not here because he'd be able to be more well versed in terms of what are the extremes that they can handle. But the ones that I use was Structural Solutions, which is a subsidiary of Group 5, so you could always ask them, but I'm unaware of what the extremes are that they can handle.
Okay, thanks, Susan. I just need to find out from, it doesn't matter whether if it's concrete, cast in situ or the precast concrete slab. What is your final riding surface in terms of, do you have a surfacing or that portion of those, of that material? Is it forming the wearing course, or can one still put a surfacing there? there, so that maybe one can provide some road markings, or you do the road markings directly on that?
So for this particular one that we did, it was for a mine, so it wasn't for channeling of traffic like you would have in a freeway. So we didn't have any line marking. So the appearance wasn't an issue at all. It had to be functional. So the concrete base was basically the final surfacing, and then you would obviously just texturize it so that you get a bit of traction on it. But other than that, we're not concerned about the aesthetics of the concrete. It was more that it shouldn't shatter and show signs of distress. It was within the concrete lined areas, there was no channeling of traffic, so we didn't need road lines. So that was not the function, so it was literally a concrete surface. But typically, like you would get on any concrete road, it was just basically a rough surface.
Alright, thank you so much, Isanda. We just want to, well, at the end of the program right now, I just want to say thank you to everyone who came tonight. Really, really, really appreciate it. We'll be serving refreshments right outside here. And we just also want to give the presenters thank you gifts for presenting to us so nicely. So you can Spongy, Lesi, Sanda, and Crystal, please join us here at the front. Yeah, so there's some goodies in the bag. So I'm just going to say thank you so much for presenting your program to us.
Don't you want the certificate in the picture?
Yeah,
Alright guys, we've come to the end, so we can just go to the foyer and have some refreshments. Thank you so much.